This block can be used as a standalone block, as a snatch block, as a stanchion block, as a sheave block, and because it's stackable, it can be combined into a 2-to-1 or a 4-to-1 or a 6-to-1, whatever is required. In this video, I'm going to show you why I felt the need to create this, why it can't be patented, and how you can get some for yourself. In our sailboats, we have dozens of blocks, and it looks like they are all different. And in order to have redundancy, we have to carry a huge stock of blocks just for when one of them breaks. This line right here is what furls our mainsail in, and usually there's a block right here. If this block breaks, I'm going to have to take this line through all of the blocks. And failure never happens during the day when the seas are calm. It's always in a blow during the night, so that's a lot of work. Last year, a 3-way block decided to explode on me. It dropped its balls all over the deck. And of course, it was one that I didn't have a replacement for. And of course, we were far away from everything. Well, right then and there, I decided I had to create something that would allow me to replace any block when it fails. This is what I came up with. Before I show you how I made this and how it works, we need to address something important. I've been developing this for months, and naturally, my friends asked me, are you going to patent it? And the answer is no. Actually, quite the opposite. I'm giving it away to the sailing community. By making this video, I am ensuring that no one can patent this, not even me. In the world of intellectual property, this is called defensive publication. By putting the design, the mechanics, the function of this block into the public domain right now, I am creating prior art. This video is proof that the invention already exists and it belongs to the sailing community, so that a big company can't patent this tomorrow and then come after us. I never ever ask this on my videos, but this time it's important. If you can share this video with your friends or your sailing community, that would be amazing. I am making the technical drawings available to everyone, so if you want to make your own, you are very welcome. And if you're a big company and you want to start manufacturing this, maybe send me a case of beer. For the sheave, I decided to use polyamide 6/6. It's a type of nylon. Sometimes it's referred to as the titanium of plastics. I chose this material because it's practically indestructible. It has very low coefficient of drag against the aluminum or aluminium and gets tougher with water. What I mean is, as it's kept humid, it becomes less stiff but more impact resistant, which is perfect for this application. And it's self-lubricating. Nobody likes a squeaky block keeping you up at night when you're off watch. The only drawback? It is one of the most, if not the most expensive polymer available. Okay, let's test the sheave we just made. And to test it, I'm gonna hit it with a hammer. Yeah, I'm hitting it as hard as I can. We have damage, of course, where the hammer hit, but it did not break. Now, one of the cool things about nylon, it's that this is basically the same thing they use to make fishing line. So it's super, super elastic. Oops, it popped out of the vise there. Let's put it back into the vise. So even if you put a lot of pressure, it popped out of the vise again. But you get the point. Even if you put a hell of a lot of pressure, it's not going to destroy itself. I'm also going to test this sheave. This is from a well-known brand, and it's one of those that has bearings going through the sheave. Because I don't understand why they break. It's not marked, so I can't tell what kind of plastic it is. But what I can do is test it. Oh crap! That just exploded. It just exploded into tiny little pieces. So yeah, I'm very confident this will do the job. For the body, I used space grade CNC machined aluminum. I can't say that with a straight face. All aluminium is space grade. Saying space grade means absolutely nothing. I mean, satellites or rockets use many grades of aluminum, and some of them are super weak, designed to shear or act as a fuse. So if you use that aluminum, does it mean it's good? It doesn't. What I use is certified 5083 H111 tempered aluminum. Certified being the key here. If it's not tested and it's not certified, you don't know what you're actually getting. To test the block as I went through the iterations, I needed a test rig. So I made one in the garage. My wife loves it that we can't get the car in here anymore. Anyway, it's made out of wood, but it's pretty strong enough. On this side, I have 5-ton lifting crane. It's on a 3-to-1, so all of these chains go down here and connect to this hook. And then on the other side, we have a huge shackle, which is where I attach the rope or the block or the chain, whatever I'm testing, and I attach it from here to here, and then we can pull it and stretch it until destruction. So in this case, the line broke over here. There's still one strand. The block survived fine, and this is a 12 millimeter rope, but I can see a problem. It opened up over here. Oh, I know why. Back to the drawing board. Right now, our sailing block is stuck inside of a piece of aluminum like this. To bring it out, after updating the model in the computer, I have to create a new G code, which is this code right here, that is literally thousands of lines that tell this robot how to move in order to free our block from inside a block of aluminum. Here is the new version. I made this thicker, so now when we put a shackle in there, it's tight compared to the old version where it had a lot of play. Now it doesn't. And when you put the pin in there, it will hold it shut so it doesn't have a tendency to open. I guess you could always, if you wanted to, reinforce it with a screw on each side. But yeah, you should not be trying to hold 3 tons with a single block. Anyway, let's test it. Here's the setup. I have a 12 millimeter line and I have 2 bowlings. I know the bowling is not the perfect knot. If it was spliced, it would be better, but most of the time we use bowlings on the boats, so it's perfectly good enough. The line broke and the block is perfectly fine, running smoothly. I couldn't be happier with that. That's exactly what we want. This is my favorite sailing, it used to be my favorite sailing block. It's from a very well-known brand and it doesn't have ball bearings. It has a huge, very thick stainless steel frame going all around it, so it's super, super strong. I hate to destroy this, but we have to, for science. It's not really a fair test because these blocks are completely different in size and this one weighs much, much more. But I want to find out if my block can stand up to my previous favorite block. Let's test it. I have the block connected to the other block with a Dyneema sling. Mounted like this, it should hold more than 5 tons. That took quite a bit of force. Oh no! My previous favorite block. Ooh, this is still under tension. But yeah, we have a winner. Let me untension this and see how it is. Both blocks did extremely well. I'm super happy about the results. As you can see, this one inside, it has a huge stainless steel frame, and it is stainless steel all in here as well, and it was deforming. It really deformed a lot. I don't know if you can see in here. This section was really thin. The shackle is all deformed as well. It's all bent. But what failed first was the sheave. You know, under such extreme forces, something has to fail. These shackles they break at about 3 tons. Just for context, that's the weight of a full-size Humvee. So yeah, that's that. I'm sorry, little guy, but sacrifices need to be made. What about our block? Our block, on its side, the shackle bent as well, but because it's much more supported, it didn't bend as much. There's a little bit of elongation right here where the pin bent, but nothing too major. It still works fine. The sheave still turns freely. And let's see inside if we can see some damage or something. Yeah, that part of the body looks perfect. The sheave looks perfect. It's not even ovalized. Yeah, because, you know, this material, even if it deforms, it goes back to its original state. Well, to a point, of course. Yeah, I'm super, super happy with that. I trust this block to take on any load on the boat. I also did some drop testing to test the impact load on the block, but the setup was so sketchy and the results so uneventful that I'm not gonna bore you with them. Let's just say that the only thing I managed to break was my back. Now that we know that it can handle pretty much anything, what can it do that makes it special? Well, on its own, you can use it with an 8mm shackle, or if you want, you can use soft shackles as well. These holes on the side are 6mm, so a 5mm soft shackle fits here perfectly. Because I designed it flush and with all these holes, it can be mounted as a sheave block. All you need is some bolts, and you can attach it to the mast or the boom or the deck, wherever you need a sheave block. And because it's flush, it's stackable, which means if you need 2 sheaves, you can put one on top of the other, or 3, as many as you need. It can also be used as a snatch block. Let's say you have a line and you can't get to the ends, you just swivel it, put the line through it, and close it. And there you go. You have the line inside of your block. Talking about lines, it can handle up to 14mm line. This is an 8mm line. This is a 10mm line. This is a 12mm line and a 14mm line. This is a big line, but it still works fine in here. I designed it with a radius here. And also on the inside, there are smooth radiuses. This means you can mount it on a stanchion or on any pipe or tube that you need to mount a block to. Using these holes on the lower part of the block, you can put a soft shackle through it and you can connect a line to it. That allows you to create an easy 2-to-1 with 2 blocks. Here's where it starts to get interesting. Because the block is stackable, it means you can stack 1 or 2 or 3 or more, as many as you want. All you need is to take out the existing bolt, and these are regular standard sized bolts, nothing special here. You get the stack you want to make, put it together, and now if you want, for example, to use a shackle, you just put the shackle in place. Now you have a 3-way block. And if you need to hold a line down here, as you sometimes need to do, and now you have a block that will let you hold a line down here. If you want, you can also get some more bolts depending on what you're hoisting, and you can reinforce it because all of these holes line up. Basically, something like this. I still don't have a name for this block. I've been calling it the super duper sailing block, but that's no good. This is like the Swiss Army knife of blocks, so maybe Swiss Army block? I don't know. If you have a good idea for a name, put it down in the comments. Maybe you'll be the one to name this invention. We have to address the elephant in the room, which is galvanic corrosion. I am using 316 bolts, and next to aluminum, we all know they create galvanic corrosion. I looked into using aluminum bolts, but they are super difficult to get and they are not as strong, obviously. And that would defeat the purpose. If I need to replace a bolt or find a larger bolt or whatever, and I'm in some remote place, there's no chance I'm going to find aluminum. So what I'm going to do is use a little bit of Tef gel when I mount it, or even marine grease, and that should keep the corrosion away. The thing is, these are totally serviceable. They are made for 3 parts, so any part can be replaced at any time. But aluminium tracks are bolted to the hull with stainless steel bolts. This one is 40 years old and still pretty good. So it can be okay as long as you keep an eye on it. This turned out so well that on my boat I am replacing almost all of the blocks because I like this one better. But that's not what I set out to do. The goal was to have a block that just by having a few aboard, it was kind of insurance and I could replace almost any block that eventually will fail. And yeah, mission accomplished. Now, I know most people don't have a CNC mill on the kitchen table, so I decided to make a pre-circumnavigation batch of these myself. These aren't coming out of a factory, they are coming out of my workbench. And these are the exact same block that I am trusting to take me and my family across an ocean. Every block helps us get a few miles further in our journey, and in return, you will be getting a piece of gear that, frankly, should have been invented decades ago. I've put a link in the description with all the details. And if you're the DIY type and you want to make your own, the CAD files are there for free as well. Thank you so much for being a part of this. And if you're still watching, you're a freaking hero. And to all our superheroes out there that support the channel, thank you so much. I really appreciate you guys. Cheers. Bye.